finally, for this section, we do need to review fairly quickly some of the formulas that you may need. And if you are watching this video and you're not in one of my classes or one of the classes that is using this textbook at Tulsa Community College, then you may want to pause the video and just write down some of these formulas, because these are things that you will be using over and over and over again in your math career. So just some general formulas: areas, perimeters, volumes, surface areas of all of the different figures. So these are dealing with squares, rectangles, triangles, and then also some of our solid figures, our rectangular solids, our circular cylinders, those types of things. So let me move forward to the next page. These are also some formulas that you may need: your circle formulas, your cubes and cones. The cones and the right circular cylinder, these are ones that, they're just very hard to memorize. The others, though, you should know pretty much off the top of your head. I also added a couple of other things that you will maybe need to refresh on, that you may need later on, either in this class or in another class, that talks about angles. Remember that supplementary angles add up to be 180 degrees. Complementary angles add up to be 90 degrees. You'll see that quite often in different math classes. Now what I want to do is I want to do an example of using one of these, a formula, in order to actually find some information. So this problem says the model m equals negative 0.85a plus 217 was developed by Miller to determine the maximum heart rate m of an individual who is age A. Now, you may notice that I put a black dot in here. That's because I made a small typo whenever I had typed up this paper. And it made a huge difference where the decimal point was. So that should be negative 0.85. Now, the actual problem says solve the model for A. So if we're starting out with m equals negative 0.85a plus 217, and we're supposed to be solving for A, or getting A all by itself, well, right now A is being multiplied to 0.85, and it also has 217 that's added to that. So let's undo these operations one at a time. Let's subtract the 217 first, so that we can remove it from this term altogether. So when we do that now, we have m minus 217 equals negative 0.85a. Now we're still not done, because we need a to be alone, and it's still being multiplied by this number. So the opposite of multiplying would be to divide both sides by the negative 0.85. Now we have m minus 217 over negative 0.85 equals a. And they may not like the negative on the outside here. You could even just bring it to the, I'm sorry, they don't like it in the denominator. It just doesn't look very pretty. We could bring it out to the very outside, and that would be a little bit more proper. Now it says, according to this model, what is the age of an individual whose maximum heart rate is 160? Now that we have the formula, we can just plug that in. So that would be negative 160 minus 217 over 0.85 would equal their age. And when we do 160 minus 217, that's going to give us 57 divided by 0.85, and we're still taking the negative of that. So 57 divided by 0.85, well, that would be negative 57 rather, 160 minus 217, so sorry. So this is going to give us a negative number, and then when we take the negative of that, it's going to be a positive. So A should equal 67 years old.